Good evening, ladies and gentlemen, students. This is Art Johnson, one of your teachers in our Astronomy 104 class at TMCC, and today is August 24th, 2020. I want to talk with you this evening about comets. I chose the comet topic to go out of the gate with because we recently had a most wonderful comet, and I would like to know how many of you saw it. So when we come to live question and answer time at the end of this, I would be interested to have you indicate if you actually got out and witnessed the comet that we have with us right now. Comet comes from a Latin word, coma, meaning hair. The ancient Chinese referred to them as hairy stars or bearded stars. Here are some records from Chinese history showing various comets. We can take it as a given that human beings of whatever culture knew about comets because thousands of years ago people looked at the nighttime sky. There was not much option other than to look at the sky, no books, no TV, no internet. And so our ancestors were more familiar with the sky than most of us are today, I'm quite certain. But anyway, the Chinese did not seem to have a negative view of the broom stars or the comets, but such was not the case in Western culture. For whatever reason, comets got a frightening, fearsome reputation. They were taken to be harbingers of all kinds of doom. I want to read you a really funny quote, or at least I think it is. This was a comet that was seen in 1528, and listen to what the French astronomer Ambroise Paré had to say. This comet was so horrible, so frightful, and it produced such great terror in the vulgar that some died of fear and others fell sick. It appeared to be of excessive length and was the color of blood. At the summit of it was seen the figure of a bent arm, holding in its hand a great sword as if about to strike. At the end of the point there were 3 stars. On both sides of the rays of this comet were seen a great number of axes, knives, blood-colored swords, among which were a great number of hideous human faces with beards and bristling hair. Don't know what he was looking at, but that's one of the classic quotes about comets from the late Middle Ages, early Renaissance. So there's Paré's drawing of what he thinks he saw. But elsewhere in Europe, comets were similarly feared. Here are some drawings and some artwork depicting the comet as pretty much bad news. Here is a great comet, one in 1577, depicted over Prague. In Shakespeare's Julius Caesar, Calpurnia, his wife, says to Caesar, "When beggars die, there are no comets seen. The heavens themselves blaze forth the death of princes." And she urged him not to go to the forum that day, and well, we know what happened when he did. In recorded history, there have been something less than 7,000 comets seen and written down, recorded. Of these, roughly 400 are repeating comets that have been seen at more than one return to the sun, and thus about 6,200 were one-time only comets or have orbits so big that they've been seen once in recorded history and they've not made it around for a second visit just yet. The most famous comet, Halley's, has been seen every 75 or 76 years since at least 240 BCE. My big chance to see it was back in 1986, and I went to Virginia City with my telescope and got a view of it. It wasn't too spectacular, but at least I could claim that I had seen history's most famous comet. The shortest period comet known is a rather bland comet called Encke's Comet. It goes around the sun once just every 3.5 years or something like that. Well, why is it that comets were feared in the Middle Ages? It's useful to remember that until about 500 years ago, a lot of people did think the Earth was flat. that the planets and stars were attached to crystalline domes that whirled around the Earth, which was at the center of the universe. So people understood the planets in the manner of speaking. They understood the seasonal appearance of different stars and constellations. But when a comet came along, nobody knew what to make of it. They were unpredictable, and you kind of hate what is feared, and you can't predict what it is, so it must be something bad. And thus, at least in Western culture, the comet as a harbinger of doom was the rule of the day. Well, about, let's see, roughly 1543, this fellow, Copernicus, published a pretty radical proposition which said the sun, not the earth, was at the center of the universe. He wisely waited, pardon me, wisely waited almost till he was on his deathbed to publish it because he knew this was going to be a controversial idea. And indeed, Galileo was put under house arrest at the end of his life for daring to suggest that Copernicus was right and that the sun was the center of the universe, not the earth. Well, it didn't take too many years for this idea to be affirmed and demonstrated. And today we, of course, understand that the sun is the center, not of the universe, but of the solar system. And here's a rather old diagram. It was made back when Pluto was still a planet, but it shows the planet orbits and three cometary orbits. The yellow one, Comet Temple 1, is a comet that takes only 5.5 years to circle the sun. It never gets out any further than just about the orbit of Jupiter. The green orbit is Halley's Comet, and as you see, it does go out just past Neptune. And in fact, we saw it in 1986, and in just 4 more years, in 2024, Halley will reach aphelion, which is its farthest point from the sun, after which time it'll start falling back in towards the center of the solar system. And many of you hearing my voice, I hope will be around to see it and show it to your children when it comes our way in 2061. Well, this fellow Halley got the comet named for him. Now, he wasn't the first one to see it, but he was the first to realize that people had been seeing this comet repeatedly. He saw it in 1682, and looking at its orbit, he realized that 76 years earlier, there was another comet, similar in appearance, that seemed to be following the same orbit, back in 1607, in fact. Then he went back another 76 years to 1531 and found another appearance of a comet that seemed to have the same orbit. Well, Halley knew about Newton's law of gravitation, he knew about Kepler's laws, and before he died, he predicted that the same comet would be seen again in 1758. It was seen on Christmas Eve of 1758 by Galle at the Berlin Observatory, and ever since that time, people have honored Halley's memory by naming the comet for him. Going back in history, it's there all over the place. It goes back at least to 240 BC. Here it is, woven into the famous Bayeux tapestry, which was a historical fabric made in France. And here it is shown in the year 1076. And just in the next panel off to the right, it shows King Harold of England being deposed by William the Conqueror. One apparition later, here is another depiction of it in a medieval manuscript. The story is almost certainly not true, but it's still kind of a one to chuckle over. Supposedly one of the popes excommunicated Halley's Comet in the year 1456. Well, coming forward to the 20th century, this is what it looked like in May 1910, photographed from Southern California. I was doing research for a planetarium show back in 1986, excuse me, and I went to the Reno Evening Gazette and found a headline that said, Halley's Comet is now seen over Peavine Mountain every night. That's kind of a cool thing. This is what we saw in 1986, and in 2061 it should be much brighter than this because it will be on the same side of the sun as the Earth is. Back in '86, the comet and the Earth were on opposite sides of the sun, so it didn't get as bright as had been seen in earlier times. Well, what the heck is a comet anyway? We talk about the nucleus, which is literally the icy, rocky, solid chunk of stuff that is 99% of the mass of the comet. It's just a big, dirty snowball. When the dirty snowball is far away from the sun, not much happens to it. It just moves along in its orbit. It doesn't get enough heat and light from the sun to boil off any gases, and so it's dormant. But when a comet nucleus comes near the sun, gases do start being liberated, and the comet develops an atmosphere for a time. We call it the coma, or head of the comet. And as the nucleus gets still closer to the sun and warms up, the solar wind blows away material from the comet into a tail, which is sometimes millions of miles long. Now, comet nuclei come in a variety of sizes. The average is thought to be around 6 miles in diameter. Call that the cross-section of the Reno-Sparks area, so that's a pretty big object. Smallest one ever seen was Comet Hartley, which had a nucleus 3/4 of a mile in diameter, and the largest nucleus ever detected was that of Comet Halebop back in 1997 with a diameter of 60 miles. Wow. Well, you know that comets move around the sun, except for a few. The ones that don't move around the sun are in what are called hyperbolic orbits. They are from deep space. They come near the sun and are deflected perhaps by the sun's gravity, but they are ejected from the solar system and really never are captives of the sun. We have seen a few of these. However, most of the known comets are in elliptical orbits, and the ones that are almost a circle are a relatively short period, and the ones that are an extremely elongated or highly eccentric ellipse can take hundreds or thousands or even millions of years to go around once. More of this later. We divide comets somewhat arbitrarily into short period comets, whose orbits are 200 years or less, and long period comets, which are comets anything above 200 years. These comets are thought to come from two different reservoirs. The Kuiper belt is a donut-shaped region of comet balls out somewhere beyond Neptune's orbit, and it's roughly in the same orbital plane as the planets. So when we see short period comets, they generally move as the planets do, roughly in the same plane as the Earth's orbit. Longer period ones come from a huge cloud called the Oert cloud, which goes anywhere from 2,000 to 100,000 astronomical units out from the sun. And these long period comets seem to come in completely random directions. That is, they are not favored the plane of the ecliptic. You can have some that come in at 90-degree angles to the ecliptic plane. And here's a representation of the Oort cloud, which is the more distant of the two comet reservoirs, and the Kuiper belt. Well, we didn't really have a close-up look at comet nuclei until about 1986, when Halleys was coming around, because it was by now the dawn of the age when humans could send probes to the planets and now to comets. So a Giotto probe, which was launched by the Italian Space Agency, was the first to reach Halleys Comet, and here is a picture of what Halleys Comet looked like in that year. You can see a great big puff of white gases at upper left, smaller one perhaps below that. These are places where volatiles, gases, are being ejected from the dirty snowball. Here's a schematic diagram showing what a comet nucleus is thought to be. Well, as spacecraft got better and the video cameras aboard spacecraft got better, we got really wow pictures of a number of different comet nuclei. This happens to be the nucleus of Comet Hartley, and I mentioned that a while ago. It is the smallest comet nucleus known to exist, about 3/4 of a mile from one end to the other. Again, you can see the gases boiling off from the ice ball as it begins warming up and approaching sun. Here's another comet that shows us, in all likelihood, two ice balls fused together way out in the Oort cloud. You can really get the idea that these two objects must have just bumped together and been bound together by gravity. This is a pretty good sized comet, just to give you an idea. If it were to fall on West Los Angeles, well, could ruin the rest of your day. Back in 2005, NASA produced a two-part mission that went out to see Comet Temple, and part of it was an orbiter. The other part was an impactor, which deliberately smashed into Comet Temple and formed a 500-foot diameter crater. But the science of what was going on there was pretty cool, because with spectroscopes and other instruments, the main orbiter was able to determine the makeup of the various gases, and also something about the particulate matter, the silicates and other things that are in the dirty snowball. I want to take a walk down memory lane with you and speak about some of the famous comets in history. This was the Great Comet of 1744, also called the Halleys Comet, had 7 tails. Wow. In 1843, the comet with the longest tail yet recorded was seen. This was a tail over 2 astronomical units long. Since this is our first class meeting, you may or may not know that an AU, or an astronomical unit, is defined as the average distance between Earth and the Sun. So in this drawing, that's twice the Earth-Sun distance from the nucleus or head of the comet at lower right to the end of the tail at upper left. And by the way, this drawing shows something we know to be true. Comet tails are so rarefied that you can actually see stars, background stars, shining right through them. By 1882, photography had been around for almost 50 years, and although the process was still crude, an astronomer was able to get this first ever photograph of a comet. We generally reserve the term great comets for the ones that are really bright, not even, maybe even bright enough to be seen in the daylight. Such a comet was seen in South Africa in 1910. January of 1910, the Great Daylight Comet. This is not a photograph, but it's an oil painting of this wonderful comet. The first of 2 comets to be seen in 1910. Halleys, the more famous one, came along in May, but the one seen in January was actually even brighter. And a lot of old timers telling about seeing a comet in 1910 may well be remembering this one. When I was in high school, way back when dinosaurs were roaming, along came possibly the brightest comet ever recorded in human history, Comet Halleys in the fall of 1966. It got so bright that it could be seen in daylight for a little time. I was living in Los Angeles, where it is smoggy and foggy, and try as I might, I was never able to glimpse this wonderful object. This was belonged to a family of comets called sun grazers, which get very close to the sun when they reach perihelion. The comet of this year, 2020, that I'll speak about later, got in only about as close to the sun as the orbit of Mercury, about 70 million miles. But Halleys came within 1 solar radius of the sun's surface, and the gravitation of the sun was so great that it fractured this comet nucleus into 3 pieces. But this was truly a great comet. In 1976, the year the United States turned 200 years old, we had a really lovely comet called Comet West. And what is this about comet names? We know that Hale got one named for him, but in general, we give a person's name, we honor a comet, how should we say it? We honor the discoverer of a comet by attaching their name to it. And so an astronomer named West was the first to detect this object when it was still far from the sun and very faint, but he got named Comet in his honor. Here's one for the record books. In 1994, Comet Shoemaker Levy came very close to Jupiter, so close that Jupiter's gravity pulled the comet nucleus into many fragments, only to have those fragments impact Jupiter's atmosphere. So the killer planet completely devoured this comet and all of its pieces. But I remember I was working at Fleischmann Planetarium at the time, and we set up telescopes in the front yard of the planetarium, and we could actually see these scars that were created when comets made impact on Jupiter. So Jupiter can disturb or even destroy comets that come nearby. Well, now, coming back, only about, 24 years ago, we had Comet Hyakutake, named in honor of a Japanese astronomer who first saw it. Very beautiful object. And the very following year, Comet Halebop appeared. It was visible to the naked eye for more than a year. And this is a classic comet, without a doubt, the greatest comet of the 20th century. Something I would like you to notice here is that this comet has not one tail, but two. Bear that in mind because we're going to see that again. The fact that there's two tails reveals that, in fact, the comet is losing gaseous material, which is the blue straight tail, and dusty, rocky material in the broader yellow curving tail. So, wonderful, great comet, Halebop, 1997. Now, what about two names? The Astronomical Union has agreed that if two amateur astronomers or two professionals find the same comet within a very few hours, the honor of the discovery can be shared by them both. Now, you will not have likely heard of Comet Pink, but it is actually at this moment still the brightest comet of our new 21st century. The reason you haven't heard of it, and likely don't remember seeing it, is that its orbit was such that it attained greatness while it was way south of the celestial equator. So folks in Australia, New Zealand, Africa, South America, some of the Pacific Islands would have seen this as a phenomenally bright and wonderful comet, but by the time it moved into the northern half of the heavens, it was already too far from the sun to be very spectacular. But Comet McNaught, January of 2007, the brightest comet of our present century. Dr. Case and I took this picture from my front yard in downtown Reno back 7 years ago. This was Comet Pan-STARRS. It was naked eye, but just barely, nothing to write home about. But if you knew where to look, or if you used binoculars, you could see it. Now, this is an example of a spacecraft-discovered comet. So it's not Mr. Pan or Mr. STARRS, but STARRS is an acronym for a NASA satellite which first detected the comet. And more, that's becoming the rule. We still get comets that are named for an individual, but more and more, as with Neowise, the honor generally goes to an orbiting space probe. As was the case with Comet Ison back at Thanksgiving time 2013, beautiful comet, but it came so near the sun that it essentially went in one side and never came out. The sun's radiation completely disintegrated Ison. My friend Steve Wheatcraft and I went out to Verdi in January of 2015, and using my scope and his camera, we captured this picture of a very nice comet. It was discovered by Terry Lovejoy in Australia, and this was the famous green comet. The green color came from multiply ionized oxygen atoms. So a bright green glowing comet. It was just barely above the threshold of naked eye visibility. It wasn't spectacular, but we did get to see it. I want to talk for just a minute about one of the byproducts of a comet, and that would be meteors and meteor showers. So a comet goes around the sun time and time again in its elliptical orbit. And with each approach to the sun, or approached perihelion, some of the material of the comet is lost. The gaseous material is diffused into space, never to be seen again, but the sandy, rocky particulate matter is diffused and continues to orbit the sun more or less in the same orbit as the original nucleus. So after the comet is long since disintegrated, there can still be found a swarm of dusty, sandy, gritty material going in that orbit. So twice a year, the Earth may intersect the comet's orbit, and we may get to collide with some of that material, and you get. Well, I'm coming to the newest part of my presentation. A lot of what you heard me say up till now was similar to what I would have told the class in our last semester. But lo and behold, out of nowhere and with very little warning, we got a wonderful comet called Comet Neowise. Does it deserve the adjective great? You decide. It achieved first magnitude and became an easy object to see with the naked eye if you could get away from city lights and pollution. This is a picture I took right around the 15th of July, just a little bit, about 6 weeks ago, from out north of Wadsworth, Nevada. This was a camera fixed to a tripod. It was a 13-second exposure, and wow, you can see very clearly the nucleus or the head of the comet and that beautifully curving tail. Some facts about Neowise. As you see, it was only found at the end of March, and that's the nature of the great comets. They're on very, very long orbits. They have never been seen before in human history, and when a comet is first detected, it's usually still so far from the sun that it's very, very faint. So it was found at the end of March. The orbit was calculated, and we realized that it would be reaching perihelion, that's the closest approach to the sun, on July 3rd, at a distance of about 70 million miles from the sun. It would then come within 64 million miles of the Earth about 2 weeks later, and as I say, it attained a maximum brightness of about magnitude 1, the same brightness as the brightest of the stars. Its orbit was calculated, and wow, a long, long, long orbit, 6,800 years between returns to the sun. So as I did the math on that, I think that it would last have been in our neighborhood about 1,600 BCE. Here's a diagram of it passing near the sun and the inner planets, and here's a differently scaled diagram showing the full ellipse, the full 6,800-year path of Comet Neowise. Here is quite a lovely graphic that was produced by an amateur astronomer. At the upper left, you'll see the days ticking off. Now, coming in from left, you can see the comet, and it crossed from below Mercury's orbit to above Mercury's orbit. Now here it is approaching the yellow Earth. It passed us by on the 23rd or 24th of July. And at this moment, as we reach the very end of August, Earth and comet are moving away from each other very, very rapidly. Well, I knew it was coming, and I made every attempt to there so that I could photograph it. My friend Steve Wheatcraft joined me on Windy Hill, if you know where that is, the morning of the 4th of July. We both set up our cameras and took many pictures, and I went home thinking I had not captured the comet at all. But I was wrong. This frame, this is my so-called discovery frame, does have the comet in it. Take a good look. Do you see it? I didn't either. Finally, I spotted it, and then I enhanced it quite a bit using Photoshop, and by gosh, there it was. It was strong twilight, but this comet was already at magnitude 1. I blew up the picture a little bit more, and this is the best I could make out of my first image. I won't say it was a discovery image, but it was my discovery of this lovely comet. Well, lots and lots of people got interested in going to see it. On the morning of Le 14 Juillet, July 14th, or Bastille Day, I drove up to Geiger Grade and discovered I wasn't the only one. There were quite a number of folks up there with telescopes and telephoto lenses, and we wanted to photograph it. It had migrated from the morning sky into the evening sky, and we were not pointed. There it is. Remember the Gazette Journal or Gazette talking about a comet seen over Peavine back in 1910? Well, here is a comet over Peavine 110 years later. That's Neowise. I didn't get the focus tack sharp, and I'm sorry, but you don't get a second chance on these things, or if you do, you have to go back a different night. Here's a time lapse, and I think you'll enjoy this. Let me see if I can make this go. So I used a different camera, and I just took a frame every few seconds, and as it grew dark, the comet dropped lower in the sky and approached setting. Night after that, I went up to my neighborhood, and there's a little public park up there above Reno High School, and lots of folks were out seeing this comet for themselves. This gives a really honest depiction of what could be seen. The couple viewing the comet had a little pair of binoculars, but you didn't need binoculars. You could see the comet naked eye, and you can also see some background stars near the Big Dipper. My friend Steve Wheatcraft used a 6-inch telescope that night or the night before and got a beautiful composite photograph showing the head of the comet and the dust tail. The gas tail, which was blue, did not show up for a few days later, but it did. Let me show you. This was the 15th of July, and for the next 3 nights, I think the comet was at its absolute best. It was climbing away from the sun, climbing up higher and higher into the evening sky. We could see it after complete astronomical darkness. And if you look at this wonderful picture, I think that tail of the comet was probably between 5 and 10 degrees long, as seen with binoculars. Same view, processed a little bit differently. And again, remember we talked about being able to see stars shining right through the tail, and I believe you can see that. This is a picture I took with an unguided, on an unguided tripod, which means you have to keep your exposure time pretty short, under 10 seconds, or the comet and the stars start to smear. So here's another view from that beautiful evening of the 15th. I decided I was going to spring for a tracking mounting, and it was on its way from the telescope store. I didn't have it this night, so I was forced to keep my shutter speeds less than 10 seconds, but I cranked up the gain on the camera, and this was a really glorious night not to be forgotten. Well, finally the tracking mount came, and my last night seeing the comet was absolutely the best comet night I have ever had in my whole lifetime. I went to the top of Dog Valley Road, which, as you may know, is a bone-jarring drive of about 2.5 miles north out of Verdi. But there I came, sat up all by myself, except for the swarms of mosquitoes. But I set up a still camera on a tripod and aimed that due north. That's the camera that you see to the left. And then I set up the tracking mount. More of that later. Here is the time lapse that I obtained just as it was growing. This is that tracking gadget that I described. I won't bother you with details except to say we aim the axis at the Earth's north pole and roughly at the North Star Polaris and turn on the motor. And then it causes the camera to counteract the Earth's rotation so you can get longer time exposure pictures without blurring. And that's what I did get. Now you can begin to see the fainter gas tail, which is blue in color, and the curving dust tail, and many background stars. This is Comet Neowise, the great comet of 2020. Really glorious object. I really hope many of you got the chance to see this beautiful thing. And here's my last time lapse that same night using the fixed camera, but it's later at night now. And look at the Earth satellites going by as the comet slowly sets in the northwest. I think that brings me to the end of my presentation on comets. So the video is going to come to an end. I'll return to you live and we'll have an opportunity for your questions and answers. Oh yeah, there's one more, I'd forgotten that. 2 Earth satellites crossing over the comet at the same time. Thank you very, very much for your attention. And this will be the end of the YouTube video. Dark on that evening of the 18th. If you'll watch in just a minute, an Earth satellite, I'm not sure which one, comes streaking into view and goes right through our visual field. This was taken over about an hour and a half. There goes the satellite off into the fading sunset. But there's the comet. There are the background stars. Really wonderful object. This is the Earth's rotation that gives the motion that we see.